There is a moment most people recognize. You sit down to do something that matters. A deadline. A paper. A problem you've been putting off. You open the document. You read the first sentence. And then, without deciding to, without even noticing the decision, your hand moves to your phone. You didn't choose that. And that's what makes it strange. You wanted to focus. You had every reason to focus. And something in you, something faster than intention, moved anyway. Most people assume the explanation is personal. They're lazy, undisciplined, not built for deep work. They've heard this story about themselves so many times they've stopped questioning it. But there's another explanation, one that's less comfortable and far more accurate. Think about what happened the last time you got a notification during something important. Not when you checked your phone, but the moment before. The buzz, the flash at the edge of your vision. For most people, that's enough. Work stops. Thought stops. Something in the brain pivots, involuntarily, toward the unknown signal. Here's what's strange about that. The notification hadn't told you anything yet. It could be meaningless. Spammed on a wall. A like from someone you barely know. You had no information. And yet your attention moved anyway, with the force of something urgent. Why would a brain do that? Why would a rational mind abandon a task it genuinely cares about for a signal that hasn't proven its worth? The answer requires going somewhere unexpected into a laboratory in the 1980s, where a scientist was watching the brain do something nobody had anticipated. Researchers had always assumed they understood what dopamine did. Dopamine was the pleasure chemical. It fired when you experienced something good. Eat something delicious, dopamine rises. Simple. But a neuroscientist named Wolfram Schultz ran an experiment that shattered that model. And what he found explains almost everything about why modern technology is so hard to put down. Schultz was studying dopamine neurons in primates. He paired a light signal with a juice reward. Flash of light, then juice. Over time, as the animals learned the pattern, something unexpected happened. The dopamine neurons stopped firing when the juice arrived. They started firing when the light appeared. The brain wasn't responding to the reward. It was responding to the prediction of the reward, to the signal that something might be coming. And here's the part that changes everything. When Schultz removed the juice after the light, when the expected reward didn't arrive, dopamine activity dropped below baseline, below normal. The brain didn't just stop being excited. It registered something like loss. This is your brain when you pick up your phone and find nothing interesting. That faint deflation. That vague restlessness that sends you back to check again 10 minutes later. That is not weakness. That is your dopamine system behaving exactly as designed, chasing the prediction of reward with more urgency than reward itself. But Schultz's discovery only explains why notifications pull you in. It doesn't explain why the pull keeps getting stronger the more you use these platforms. For that, you have to understand something even stranger about how the human brain responds to uncertainty. Imagine two slot machines. One pays out every 10 pulls reliably. The other pays out randomly, sometimes on the second pull, sometimes not for 30, sometimes twice in a row. Which machine is harder to walk away from? Every gambler knows the answer. And the reason has been understood in behavioral science since the 1930s. A psychologist named B.F. Skinner built boxes with levers. Rats pressed levers. Sometimes food came out. He tried every possible schedule. Fixed, predictable rewards produced steady, moderate behavior. But when he made the reward unpredictable, food appearing randomly with no pattern the rat could learn, the behavior transformed. The rats pressed obsessively, compulsively, in a way that no other schedule produced. They couldn't stop. Not because the food was better. Because the uncertainty about whether food was coming created a loop the brain couldn't close. Skinner called it variable ratio reinforcement. Casinos built their entire industry on it. Then, decades later, social media platforms discovered the same principle, not in a moment of cynical genius, but through the cold logic of A/B testing. Early social feeds showed posts in chronological order. Predictable. You scrolled. You saw what was new. You left. Then engineers discovered something. When feeds were made algorithmic, curated, unpredictable, reshuffled by forces invisible to the user, engagement went up. Time on platform went up. People stayed longer and came back more often. Not because the content was better. Because they could never be certain what they'd find, and the brain caught in Skinner's loop cannot easily walk away from an uncertain outcome. Every pull to refresh gesture is a lever. Every scroll is a pull. The uncertainty is the product. Now here is where it gets genuinely disturbing. You might assume this is simply an engagement problem, that the worst outcome is spending more time on apps than you intended. But researchers have started asking a different question. What does living inside this loop actually do to the brain's ability to focus on anything else? Think about a knowledge worker. Someone who writes, analyzes, codes, or makes decisions for a living. The work requires holding complex ideas in mind simultaneously, the way a chess player tracks multiple threats at once, or a surgeon keeps a procedural sequence stable under pressure. This is cognitively demanding. It requires a particular kind of sustained, uninterrupted concentration that builds slowly, like a structure needing time to assemble before it can bear weight. Now, picture that person receiving the average number of digital notifications in a modern workday. Studies have measured this. It runs between 50 and 90 interruptions per day. Notifications, messages, emails, platform alerts. A researcher named Gloria Mark at the University of California, Irvine, spent years following knowledge workers in their actual offices, watching what happened after each interruption. What she found was not what most people expect. After a distraction, people didn't immediately return to their original task. They took detours. They checked other things. They started new threads. And full cognitive re-engagement with the original task, the point where the mind was operating at the same depth it had been before the interruption, took, on average, more than 20 minutes. 20 minutes for a single interruption. The math becomes almost impossible to process. If interruptions arrive every few minutes, and recovery takes more than 20, the brain may never reach genuine depth at all. The knowledge worker moves through the day feeling busy, thinking hard, producing output, while spending the entire workday in cognitive shallow water. Not distracted enough to be aware of it. Not focused enough to produce what focus actually makes possible. At this point, you might be thinking, fine, notifications are bad, but that's a habit problem. Turn off the notifications. Problem solved. But researchers discovered something that makes that response feel insufficient, almost naive. A team of scientists ran an experiment with college students. The students were given a cognitive task, a working memory test, the kind that measures how well the brain holds and manipulates information. The researchers varied one thing, where the students' phones were. Some students had their phones on the desk, face down, turned off. Others had their phones in their pockets. Others had left their phones in a separate room entirely. The students who left their phones in another room outperformed the others. Not dramatically, but measurably, reliably. The students with phones on the desk, silent, face down, powered off, performed worst. The phone didn't need to be on. It didn't need to produce a single notification. Its mere presence in the attentional environment was enough to pull cognitive resources toward suppressing the awareness of it. The act of not thinking about the phone was itself consuming mental bandwidth. This finding, published by researchers at the University of Texas at Austin, points to something more unsettling than a habit problem. It suggests that for heavy smartphone users, the device has become a persistent object of attention management, requiring active cognitive effort to ignore even when silent. That effort isn't free. It comes out of the same mental budget you're trying to use for everything else. There is a generation alive today that has no personal memory of what it felt like to be bored in a way that couldn't immediately be resolved. People who were teenagers in 1995 remember a specific quality of waiting. Waiting for a bus with nothing to look at. Sitting in a doctor's office with a year-old magazine. A long car ride with only the window. That boredom was uncomfortable. And that discomfort, it turns out, was doing something. Neuroscientists studying what the brain does during undirected rest have found that the mind doesn't go quiet when attention is released. A set of brain regions, connected in a network that activates specifically when people are not focused on an external task, becomes measurably more active. This network, called the default mode network, appears to be involved in processing memories, simulating future scenarios, integrating emotionally significant experiences, and generating the kind of spontaneous associative thinking from which creative insight often emerges. It is, in short, what the brain does when you give it nothing to do. And every behavioral scientist who has studied it describes the same function. It is the mind working on itself, quietly, below the level of conscious effort, processing what happened, rehearsing what might happen, making meaning from the noise of experience. When every gap in a day is filled with a phone, that process cannot begin. The silence that used to allow something to surface, a realization you needed, a feeling you hadn't fully understood, an idea that needed uninterrupted time to form, is preempted before it can start. What you lose is not just focus. What you lose is the mental process by which a person becomes more than the sum of their inputs. It is worth saying plainly what the evidence does and doesn't show. It does not conclusively show that smartphones have permanently damaged a generation's brains. The research is largely correlational. Causality is hard to establish. There are competing explanations. Researchers disagree about magnitude. What the evidence does show, robustly across multiple fields, is that an environment has been built that is structurally incompatible with how the human attention system functions. That the financial incentives of the companies building that environment run directly against your ability to focus. That the psychological mechanisms being exploited are not personality flaws. They are standard features of every human brain, operating exactly as they evolved to operate, in conditions they did not evolve for. People in 2026 are not weaker than people in 1985. They are not lazier, less disciplined, or less capable of depth. They are the same animal, placed inside a machine optimized to consume their attention at scale, a machine built by some of the most talented behavioral engineers in human history, funded by capital that depends on the machine running continuously, tested and refined through billions of hours of human behavior, until it became, for many people, genuinely difficult to resist. There is a question that tends to end conversations about this, because it sounds conspiratorial but is actually just financial. The companies that build these platforms make money from attention. More attention, more money. Less attention going elsewhere, to books, to thinking, to sustained work, to the kind of boredom that turns into something, means more attention available to them. There is no secret meeting where engineers decide to break your focus. There doesn't need to be. The incentive is enough. It flows through product decisions, through A/B tests, through performance reviews, through quarterly earnings calls. Every feature that keeps you on the platform longer is a good feature. Every moment of unmediated thought is a missed opportunity. The question is not whether you're failing to focus. The question is what kind of world we've decided to build, and for whom.